All right. So today I had this sudden, compelling feeling that I needed to show how I made my brick game for the gametank. So I think this is mainly for the gametank developers out there, or people who are interested in doing gametank development. Because when I got started, I had a lot of figuring out to do, and I just find this stuff really interesting. And I like to think that when I make videos, I try to think of videos that I would have wanted. So whether that reaches one person or lots of people, I think doesn't really matter to me, because it would have found me eventually. And so when we invent time travel, I'm doing myself a favor. Does that make sense? Probably. Yeah, so I'm going to show you my game. So this is Visual Studio Code. My project is called Paddle Tank. When I made it, it was I knew it was going to be a game tank game, and I pulled the gametank C SDK repository, and I didn't know what I knew. I was going to make a game for paddles because I was designing a paddle. So quick refresher for if people don't know. Let's switch camera. This is a well, I've never showed this. This is a new version of the paddle controller I'm developing for USB. So it's like for PC, Mac. It's really just a RP2040 microcontroller with a potentiometer and one button. And I'm just trying to find a nice, convenient, little, cheap, simple enclosure for it. So this is the first prototype enclosure. Switch back. And this is... Oh yeah, so just to explain the paddle controller again, I just showed you the USB version, but what I really was making when I started developing this game was I came up with a way to use the digital inputs of the game tank to sort of simulate, I guess is the way of putting it, to sort of simulate or translate an analog input. So the gametank controllers have 4 unused bits, or button presses is really how they're interpreted in the cabling. So I took advantage of those 4 unused bits, and I also took the up, down, left, right D-pad inputs to get 8 bits of information and send that to the gametank, to this SDK. And then I came up with sort of like a new header file where I'm interpreting these new bits as a paddle rotation. So first thing I want to show you is the game. So we'll emulate that. And I'll be using my paddle, although you can just use keyboard emulation. But anyway, the A button is the button on the paddle, so I conveniently mapped it in the game to trigger paddle mode. And then press start again, and then it starts again. So now what I like about paddles, what I always try to demonstrate, is the speed of the input. It's like lightning fast, basically. Whoops. Always try to I always try to get that extra ball when it appears. Hold on, I gotta turn that down. Okay. So maybe I could talk about the game, how it's kind of generating levels and stuff. All of these bricks are procedurally generated, so that's what the loading screen is at the beginning of every level. It does kind of a mathematical division of 120 columns, and kind of draws in the shading lines for all of the bricks. And the dissolve effect when you hit a brick is also procedurally generated before the game begins, so that's why there's a slight delay when you start from like switching the console on. So if I hit reset, there's that delay. That's doing the math to generate the animations, the dissolve animations, so that when I'm in the game, the dissolves are drawing on top of each brick, and they're pulling from an area in memory that has like a whole vault of dissolve lines going down. So it's like it occupies the full sprite width, so that in theory you could have a brick that's dissolving that's 128 pixels wide. It's not necessary, but it exists as like sort of like animation sprite information that's available at any brick size. And what's nice is there's enough variation in the animation information that every brick is dissolved slightly differently. Or it might not be exactly how I'm describing it. It's not like every brick is unique, but there is like a staggered math in the way that it samples the animation frames. Okay, that's enough talking about the game, I think, because I want to keep this relatively short. I think I'm thinking of this as part one of a series if it seems like people are watching them. Or I don't even know if people need to watch them. I think I'm going to want to talk about it anyway, but it's just that there's a lot of information, and I want to keep these relatively short. So part one in a series of me talking about how I made Brick Game for the gametank. So basically it's the gametank is a 6502 processor-based game console. It's a physical console, and obviously I'm running it in emulation on my Mac, and the emulator is also a really cool thing, but it's interesting because in a way I've also made like a multi-platform game. But because I had to stick with the constraints of the 6502, it looks almost like developing for the Pico 8. It sticks to those limitations, and you get a very unique game experience. I think what I wanted to do was go through line by line through my main function, which it's really this short. It's whoops, let's move that down. It's about, where is it? It starts here. There's some kind of emulation stuff here, which I don't really think I'm going to talk about. It's a little trickery, but there's some initialization going on. There's sprites being loaded, and there's like memory bank switching already. this is the animation thing where I'm baking the sort of random dissolve effect. There's ball physics system, I guess. This is the animation frames being generated. This other thing was like gradient noise, I guess, is what I'm calling it. This was me putting in the version number in the opening screen. Yeah, what this is doing is it's baking the number digit by digit into the sprite bank that the titles were loaded into. And then we're generating the level, setting the game state, and then we go into the loop. So one of the really interesting things I want to talk about, let's see, am I jumping too far ahead? Maybe just for people who are just starting out. Usually when you look at the documentation, you'll see a lot of assembly stuff. That kind of went over my head, so I jumped straight into the C SDK, which is what this is. And normally what you'll see in the C SDK is like 5 lines of code here. It's gonna you'll usually see something like, I thought there would be a all right, maybe there's some level of there's like a clear screen thing, which I think I have it hidden away in a function somewhere. But in my main loop, in my while loop, infinite loop, what we're actually seeing is we're clearing the border. I think otherwise, if I didn't have this here, instead of those gray edges, you have like I think you'd have noise. I just got so used to having this here, I forgot what it does. But it happens every frame. I have my state machine. So I guess the state machine runs, makes all the decisions that need to be made, and then we go to the drawing of the screen. So the thing I want to point out that's sort of, I don't know if it's unique, but it's different from the sort of boilerplate project you'll find in the gametank SDK, is that usually you're going to redraw the whole screen every frame. It's sort of like the easiest way to achieve a clear loop, where you clear the screen to black, maybe you draw some background image, maybe it's the map of your game, and then you start to draw the sprites, or you draw the score, or whatever. That is a nice clear way to handle it. I chose not to do that for optimization reasons. So I'm deliberately leaving the screen sort of untouched and only editing parts that need to be changed. So when you see the ball moving around, I'm only redrawing the ball, and I'm only erasing where the ball used to be. And so that's kind of probably indicated here. So for every frame, it checks to see if the score has changed. Is that what this is? Let's see, score, refresh frame. So yeah, I think this is telling it if the scores need a refresh, do this. High score, do this. And if the lives have changed. It's kind of written in this weird way. It's not a Boolean. It's like an integer or something, because this is being handled. Actually, all of this stuff is being handled, like I said, per frame. But okay, so this is why that's this is why I'm going into so much detail about redrawing objects, is that there's two buffers and it flip-flops between buffers. So it's like, I think it coincides with the fields of like a CRT television, or just how old video signals worked, is that each field is roughly 1/60th of a second, and they alternate. So two fields actually make up the full screen, I think. In an actual CRT, I think it. Actually, that's beside the point. The point that really matters here is that there's two buffers and they alternate. So what could happen is, let's say you're following the ball around the screen and it moves 1 pixel every frame. So the previous frame, it knows where it was, so it's going to erase that. But if it's flip-flopping between buffers, then your previous frame, you're already 1 ahead of where the ball was when that frame was drawn. So you're going to end up leaving little artifacts behind, and they're going to be flickering because the fields flicker. If they're different, you're going to see it flicker. So you actually need to erase twice. So when a ball moves and you want it to have a clean trail behind it, you have to erase the 2 previous frames. Or actually, a better way to say it is you have to erase where it was 2 frames ago. So you're storing that data, and that's why I'm sort of tracking the refresh frames here. And then another thing to pay attention to is all of this stuff up here, I guess, is the queue, the draw queue. So there's 2 types of drawing in the SDK. There's direct draw and there's draw queue or something. And if you're just using the draw queue, you just put this somewhere in your loop and it waits for everything to draw so that it can just continue with the CPU, whatever the CPU is doing. I don't think I'm describing it quite accurately, but in order to draw what's in the queue and predictably know that that's been done, you have to await the draw queue once per frame, at least once per frame. I mean, you don't want to do it more than once because it'll probably slow it down. It's really interesting. You at some point in time, you're gonna have to know what's actually going on under the hood if you want to really optimize your code. So, okay, the reason why I'm awaiting the draw queue here is because I want this drawing that's all piled up to be done, and I want nothing. I don't want any of that drawing to be happening in the blitter while I go to the score refresh, because scores are being handled by the text header file, which uses direct draw. So this is the first thing you'll learn by accident, is if you pull in the text feature, you're gonna go, why is everything scrambled when I turn on text? And it's because if you're using the draw queue and you want to add text, you have to be very deliberate, like handle all the queue stuff, then do your text, and you'll be fine. And then this is all kind of boilerplate, vsync, flip pages, and you want to tick anything that needs to be ticked, any time-based functions like the music handling, you want to tick that, and you want to update your inputs. So under normal circumstances, you're going to just use update inputs, and that uses like the input masks for the directional buttons and ABC start buttons. but since I'm using paddle inputs, I needed to rewrite the input masks so that they include these 4 sort of unnamed buttons. I kind of arbitrarily named them X, Y, Z, and mode based on the Genesis controllers buttons. So that's a brief overview. I don't know, is there time to talk about more detail? How long has this been? Where's the timer? Is there a timer? Dang. Oh, it's like 20 minutes. Yeah, that might be enough. Let me just see if there's a little tease. What should I tease you with? Well, I do want to talk about really briefly then is that you can see that I'm loading all the sprites up here. So if you're just starting out, I think a really important detail to know about how this SDK is structured is that you can conveniently draw your images in another application like Ace Sprite. I thought I had it open here, but I don't. Oh, that's going to take a while. Ugh. Oh no, okay, that was quick. So like here's my title screen, and I find the palette very interesting, how it's split up into 3 different chunks of information. So from these boxes from left to right indicate saturation. So it's like 0, 1, 2, 3, the 4 values of saturation. And then top to bottom, you're going to get, what is that? Hue? Yeah. So that's 7 or 8 values. Wait, 1, 2, 3, 4, 5, 6, 7, 8. Right. So what is that? That's 3 bits. And then you also get 8 values of value, like luminescence or something. So the 8 bits of a color bit is structured with the left 3 bits is hue, the middle 2 bits is saturation, and the right 3 bits is your hue shifting. And yeah, I just find that really cool, really interesting. I was able to get pretty cool looking colors, I thought. So the general workflow is you would work on your sprite, you would go to export it, you'd do your bitmap and JSON, you'd send them into your project folder under assets, under GFX, so if it's graphics. And once they're exported, you'd over back in your project, you'd want to do a make import, and it should find all your bitmaps and things, and it'll create metadata that can be read in here. And you're also going to want to, all your generated metadata would go into your gen folder here under GFX, and all the sort of master list is, I think there's, yeah, assets. Is that it? No. Maybe GFX. Yeah, all your graphics automatically generated macros are here. So so you want to grab, like, for any bitmap, you want to grab the asset blah 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 BMP, and you would use that down in your main loop or wherever you're loading. Oof. So yeah, so I'm doing load sprite sheet. I'm using that macro, and then you set the bank. So I think you want to stay away from bank 0, and then I'm not sure why, maybe because it's fonts or something. And then you want to you can just set your banks, and that's a kind of cool thing to show actually is if you're in the emulator, you can hit escape. Hold on, let me just go through that. You can hit escape and show some of the debug stuff. You can also mute it. But I like using the VRAM viewer, which is really fun. You can see these are the two buffers. Yeah, that's your font in bank 0. This is like my background image that has the life indicator and the level number kind of baked into it. This is my sort of, this is kind of lazy. I have all my, oh no, that's not lazy. I'm thinking of something else. Those are actually the bricks that get generated. I can't see it, it's so small. And beneath it, there's 104 lines reserved for the sort of dissolve animations. This is some other, like some baked text that I made and some other sprites. This seems like a big wasted piece of VRAM, and then my title screen's over here. But it's cool because if you hit reset, you can watch it. Huh, that's interesting. I thought we would see more stuff going on here. Let's hit reset again. Seems really slow, doesn't it? Yeah, you can kind of see these things generate. Let's do that one more time. Just one more time, I promise. Let's see if we see this thing should, yeah, that regenerated. This looks the same. Something happened over here. Okay, but that was the cool. That was just a little fun thing that you can monitor while you're developing. You can watch your VRAM change. Yeah, I'm doing some fancy stuff where I'm kind of writing into VRAM. To me, it seems fancy anyway. But all right, I'm gonna call it quits because I feel like this video is way too long, and we'll see if there's a part 2. All right, see you later.